Hey everyone, welcome back to topic number 2 in our database class. In this video, part 7, we're going to discuss foreign keys and relationships between tables. I will also provide a detailed demonstration of how to implement foreign keys and establish relationships between tables in Microsoft SQL Server. Now, we have learned already during our time together in this class that in the relational database model, tables may be related to one another. And the way that we interconnect them is through matching pairs of values. Now, a few comments that I'll make on this topic before proceeding. I do want to highlight the word may because this suggests a possibility but not a requirement. So tables may be related to one another, but it is not required in the relational database model that every table be related to at least one other table. You may have one table that just hangs out here by itself and has its own unique purpose and doesn't have any relationships to, say, the other tables in your database. Okay, so you may have some kind of, I don't know, structure that looks like this, where you have three tables that are connected to each other and one of them that just sits lonely and hangs out without any relationships. So that is perfectly possible. There is no requirement in the database world that every table be related to some other table. But in reality, most tables will have at least one relationship to other tables in the database. And the reason that we have these intertable relationships is to allow us to create data models that accurately reflect the nature of the kinds of relationships we find in real world data. So, for example, we have employees that work in a department. Okay? So there's some sort of relationship there. In this case, it's like a work in relationship. An employee can work in a department can have many different employees. Or we might look at a project and manager sort of relationship. So maybe our company does lots of projects and each project is assigned a manager. In this case, we say a manager, suggesting that each project has just one manager. So perhaps each manager can manage many different projects, but each project in our company has just one manager. Okay. So these are just some examples of relationships between tables. They exist everywhere in the business world because, again, most concepts are connected to other concepts in the database in some way. For example, customers can purchase products, right? Products can be provided to us by suppliers. So we have lots of these different types of relationships among business concepts, but do keep in mind that it is, again, not required for tables to be related to other tables. Indeed, it is perfectly feasible to have a table that just lives on its own and has no relationships to other tables. So this leads us naturally now to the discussion of our other specific major type of key in the relational model, and that is a foreign key. Okay, so thus far we've learned about candidate keys, and we learned that candidate keys are, it's just like an election, like one candidate key is ultimately chosen to be elevated to the status of primary key, and that primary key is used as a basis for uniquely identifying every row in a table. And most recently, we talked about surrogate primary keys. So if we have no good natural candidate keys, or none of the candidate keys that we have seems like it would work for some reason or another, we can always introduce a surrogate candidate key and then ultimately elevate that surrogate key to the status of primary key. However, that's only one side of the relationship. Indeed, to establish a relationship between two tables in the relational database world, we're going to need a foreign key. And the foreign key will live in the other table. That is, we're going to connect the primary key in one table to the foreign key in another table. Now, typically, and I highly recommend that you follow this pattern, the foreign key in the second table will have exactly the same name as the primary key from its parent table. Okay. So these should have the same name. That is to say, for example, if I want to use something like an employee ID to identify an employee table, and I want to maybe use a department ID to serve as the primary key of a department table, and I want to connect those tables, the best way for me to do that would be to put a department ID column into the employee table. And then we would use matching values of department IDs in order to link those two tables together. However, it's important for us to know that when we are inserting one of these key columns into a table for the purpose of establishing a relationship between the tables, the key that we insert into the receiving table is called a foreign key. Okay? So basically a primary key from another table, and we're adding it as a new key in a second table solely for the purpose of interconnecting those two tables together. All right. So this is the notion of a foreign key. Here's an example. On the left, we have a project table, which a company might use to record information about the various projects that it has ongoing. In this case, we've made it extremely simple. It just has a project ID, which we've underlined to indicate that it is serving as the primary key. And then we have name, which is just a non-key attribute. And we have manager ID. And we can see we're going to use this manager ID column or attribute here in order to connect our project table to the manager table over here. So we'll be using matching values of manager ID to interconnect the rows in these tables. So here's an example of the use of a foreign key. So we've got a primary key in the manager table, manager ID, and we can see that we have a foreign key named manager ID in the project table. And the values of the manager ID in the project table point to rows in the manager table. That allows us to keep track of which manager is managing each project. Okay. So in this world here, each project has one manager, and that manager is identified by the manager ID. So if we're looking through a particular project and we want to know who that manager is, we can essentially follow the relationship line between the two tables and say, who is the manager of project number 7? So maybe that's manager number 1. So what we do is we just follow this relationship here, go over to the manager table, and we look in the manager table until we find manager number 1. And once we have manager number 1, that row, we will be able to look at the manager's name and figure out who the manager of the project is. So there's an example. Let's do another very common example. One that I use repeatedly is this notion of employees and departments. So here's an example where we have, again, two tables, and we've got our department table over here, and the departments can have many different employees who work in them. And for that reason, we dropped the department ID over here in the employee table, which we can see was the primary key here in the department table. And we use matching values of these attributes in the two different tables in order to link them together. Is we have a way of figuring out which departments each employee works in. So if I have my department table, I won't put the name on there. I'll just do it this way. Let's say we have our department ID and our department name and our location. Maybe that's like the office number or whatever. And then over here we have the attributes for our employee table, employee ID, and we have department ID, which is serving as the foreign key, and the name of the employee. So we would just have something like this, and then we can go ahead and fill in some values. I don't know, maybe in our department number 1, and that'll be our accounting department, which I'll just abbreviate as ACT. And maybe they're in room 18. All right. And then we have department number 2, and maybe that's our marketing department. which I will abbreviate as MKTG, marketing. And maybe they're in rooms and so on, right? Then we can have employee number 10, employee number 11, employee number 12, and whatever their departments are. So 1, 2, 2, and then whatever their names are, blah, 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 blah. We then use these matching pairs of values. We have the foreign key that lives here in the employee table. In this case, the foreign key is department ID. And we can then use values of department ID to figure out the details about the department in which each employee works. If I wanted to ask the database, hey, database, what department does employee number 11 work in? Then the database would solve this by saying, okay, got to find employee 11 in here. Here's employee number 11. Employee 11 works in department number 2. So I follow this relationship over here. This is my row 2 over here. I would say, okay, employee number 11 works in the marketing department. Easy enough. So that's how we would answer that sort of question. We can also ask questions in the other direction. So we can ask the database questions like, hey, database, which employees work in the marketing department? And the database would answer that question by saying, all right, is this the marketing department? No. Is this the marketing department? Yes. So the marketing department has an ID of 2. And we can then say, all right, I got to look over here. And we'll say, does this employee work in department number 2? Nope. Does this one? Yes. And does this one? Yes. So in that case, we would be able to answer the question as employee numbers 11 and 12 are our marketing employees. So primary key in the department table, department ID. Primary key in the employee table, employee ID. Foreign key, our new concept in the employee table, is department ID. And we use these matching pairs of values between department ID here as a foreign key and department ID here as a primary key as a means of linking the rows in these two different tables together. So that's the notion of foreign keys. Referential integrity is something that we talked about briefly before, but I'll revisit this concept now. The general idea here is that this is a constraint that we are imposing on the design of our database. And referential integrity relies on this concept of a connection between a primary key and a foreign key in order to work properly. So the general idea with a referential integrity constraint is that we want the database to protect us from entering an invalid connection between the rows in two tables. For example, if we are, I don't know, let me just back up a slide here. So let's say that we're in a situation like this and we want to add a new employee to our employee table. Okay. Now, if in trying to add a new employee over here in the employee table, you can see that I need to provide 3 values to do that. Right? I'm going to need an employee ID, a department ID, which links us over to the department ID in the department table, and the employee will need a name. So I need to provide these 3 values in order to enter a new row into this employee table. Now, let's say that I try to do this and I have a valid set of departments that are 1, 2, and 3, but I try to specify a value of 7 for this department ID. Now, if there is not a department over here in the department table that has a department ID value of 7, then referential integrity will cause an error when I try to enter this new row of data. So basically in this scenario, if I try to tell the database that I'm adding a new employee and that employee works in a department that doesn't exist, the database is alerting me to the fact that, hey, you're trying to specify that this employee works in a department that does not exist. But when referential integrity is in place, basically the matching department ID, the primary key side, needs to exist over here, in this case in the department table, before I can try to add an employee record that points to that department ID over here in the employee table. So this is the idea with referential integrity. I do want to highlight, before I do a demonstration here, that referential integrity constraints are optional. They are typically switched on by default in most enterprise level database systems, but you can switch them off as necessary. So put differently, it is perfectly possible to establish a relationship between two tables without enforcing a referential integrity constraint between them. Again, the default in most enterprise level database systems is to have referential integrity enforced by default, but you can switch it off. So I thought it would be take a good opportunity here for us to see how we can create these foreign keys and set up referential integrity constraints in SQL Server Management Studio. So I'll just switch over and we'll do a little live demonstration. What we're looking at now is just a little database diagram of this employees database that I use for illustration purposes. And we can see it has 4 tables that allow us to keep track of which employees work in which departments and which employees have which skills. And the level of those skills is recorded as well. For now, let's focus on this relationship over here on the left between employee and department. Now, we learned recently about the meaning of these little key symbols that we have. Okay. These are primary keys, right? We can see here that we have a composite primary key consisting of these 2 attributes: simple primary key here, skill ID, simple primary key here, department ID, and employee ID here. Now that we know a little bit about foreign keys, we can understand that department ID in the employee table is serving as a foreign key. You will note that in this sort of Microsoft's based diagramming world, there is no visual indication on the diagram that this is a foreign key. Okay? We can tell it's a foreign key because we have a relationship between these 2 tables. The primary key here is department ID, and so the column here with the matching name is almost certainly the foreign key. But again, this is just a little quirk of Microsoft's database diagramming tool. We'll see a little later on when we move into entity relationship modeling that we will typically mark our foreign keys using the letters FK, just as a visual symbol. It's a little big, but you get the idea. So a little later on when we work with entity relationship modeling, we'll learn to mark our foreign keys. But for now, we just need to be aware of the fact that, hey, department ID is a foreign key. So currently we have a relationship between these 2 tables, and that relationship is represented here by this line. And if I right click on that and select properties, we'll see that we have this little properties dialog box over here. And this tells us something about the relationship between these 2 tables. So first, if I just want details, I can open up this tables and columns specification. And if we just take a look at some of the values out here, this will remove any uncertainty that we may have about the connections between these 2 tables. Okay. So this tells us that the department table is the primary key parent table, and we're using department ID in that table, right? That's the primary key column in that table, and we're connecting that to department ID in the employee table. We can see that department ID in the employee table is serving as our foreign key column, all right? So this is just a little visual check to verify what we already suspected was true, and that is that the department table and employee table are linked together based on matching values of department ID. Now, what we see here is an option that says enforce the foreign key constraint. And in SQL Server Management Studio, this option here is how we switch on or off referential integrity. So you can see that by default, our referential integrity constraint is on, right? So it's enforcing this constraint. We could switch it off if we wanted to. But for illustration purposes, I want you to see both sides of this so that you fully understand this notion of referential integrity. So let me first just select all of the data out of the department table so we can get a sense of what's going on out here. And as you can see, we currently have 4 departments, and they are numbered 1, 2, 3, and 4. So these are our department IDs. The valid set of department IDs is 1, 2, 3, or 4. And what that means is that our employees must work in one of those departments. So let's see if we now can play around and get a live demonstration of this referential integrity idea. So I'm now going to open the employee table for editing, and we can see that we have number of department IDs here, right? Department 1, Department 2, so lots of employees work there. Here's a Department 3, Department 4. So let's try to create for ourselves a new employee. And I'll choose Dr. Cooper as my new employee. So we're going to say Sheldon was hired and we're going to say that Sheldon works in a department that we know does not exist. Let's say 99. Right. Remember, the only valid departments that we have are 1 through 4. And our referential integrity constraint is currently on. So I'm going to get an error when I try to commit that change. And you'll see the error message tells us, so the data in row 13 was not committed, error source, blah, blah, blah. The insert statement conflicted with the foreign key constraint. Okay, so our foreign key constraint, that is the referential integrity constraint, is preventing us from adding this row because there is no department 99. It doesn't exist in the department table. Right. Now, if I specify a table that does exist, say department number 3, then I can add the row without any trouble at all. So see, we no longer get an error there. As soon as I try to switch it to a department that doesn't exist, and try to save that, you'll see we get that error message again. All right. So for now, let me commit that change using a valid department ID, as we see here. By the way, just as a brief unrelated aside, if you look at this type of date format, here in North America, we use an odd date format compared to most of the rest of the world. So the pattern that you'll typically hear in North America is month, day, year. Many other parts of the world, it will be day, month, year. But this pattern here I particularly like and wanted to draw your attention to it. You'll see that this one uses year dash 2-digit month dash 2-digit day. And what I particularly like about this format is it sorts beautifully. So say you're working on, different versions of an assignment, and you store one version and maybe you store that as today's version. So you use something like this, 2022-09-12. And then say a week later, you work on a new draft of it and you save that as 2022-09-19. So naturally, when you see these files listed in the folder on your computer, they will be sorted automatically in date order, presuming that the other parts of the file name are identical. So I really like this. It doesn't work if you try to invert it and use year, day, month, or month, day, year, or day, month, year. It doesn't work. But this way, you'll always get a proper date sort. So I just wanted to point that out, even though it's not really related to what we're talking about here in our database class. Okay, so we now have our data, our new employee added. We hired Sheldon. And now let's make a little change out here. Again, here we see our 4 viable departments, 1, 2, 3, and 4. And let's go and change this referential integrity constraint. So again, in this case, instead of enforcing this constraint, I will switch it to no. Okay. And remember, when a proposed change has been made but has not yet been saved, we'll see a little asterisk, right? So we see a little asterisk there, meaning like a change has been proposed to the department table, but has not yet been saved. Okay, the same thing applies. So I'll just go ahead and save this by saving my diagram. And it'll say, hey, we've got to modify the structure of the table. Sure, go ahead. So that change has now been made. That is, we switched off the enforcement of the referential integrity constraint. And now if I try to edit my data again in the employee table, and we've got Dr. Cooper here, and let's say that we assign Dr. Cooper to department number 99. Remember, we know that 99 doesn't exist as a department, but as you can see, with the relational or referential integrity off, we are now allowed to input a number for a department that doesn't actually exist. So in this case, I can say that an employee works in a department that doesn't actually exist because referential integrity has been switched off. So hopefully you can see the value of referential integrity and can understand why in most enterprise level databases, referential integrity is switched on by default. I'm just going to delete Dr. Cooper since he was in there for illustration purposes. And now what I would like to do is just delete this relationship entirely, now that we've seen a live demonstration of referential integrity, and show you how the easiest way in SQL Server Management Studio to establish a new primary key foreign key relationship is, in my opinion, is to use the database diagramming tool, because you can just do drag and drop then. Right? So we currently have no relationship between these two tables. Let's say that we want to connect our primary key department ID here in the department table to our foreign key department ID up here in the employee table. So the easiest way to do that is to select the primary key attribute and then drag and drop it on top of the target foreign key attribute, in this case, department ID. So I drop that there. You'll see we get this relationship plug box that pops up. It says, all right, the primary key table is department. The attribute there is department ID. We're connecting that to the department ID attribute in the employee table, and that will be the foreign key table. Okay. So I click on OK, and you can see I have an option here if I want to change the referential integrity constraint. By default, it is on. I could also change the name of this new foreign key constraint if I wanted to, but I like this naming convention, so I'll allow that to stand. And when I click on OK, the relationship is added. Once I save it, it will now be a permanent part of my database structure. So pretty easy to break and create foreign keys, as you can see, and pretty easy to switch referential integrity on and off as necessary.